Hello everybody, in this video we are going to discuss about Newtonian mechanics and how to analyze the system, solve the problems. So I'm going to start from a simple example that we have here. This is a mass on a surface. Assume this is your system. This is very important to understand it at the beginning. So everything else around is an environment, and environment acts on the system. Therefore, the forces that the environment act on the system allows the system to be in a stationary position or equilibrium or moves in one direction. Suppose you have a force like F, and then this object moves in this direction. So if you assume the environment acting on this object, you have a mass and therefore the gravitational force. The surface acts on the object opposite to the surface at the point of contact, and normal. This is very important. Normal to the surface at the point of contact. Then you might have a frictional force between the mass and the surface, which you assume as F. So if you like the Newtonian second law, you can have the forces along the direction of motion, which is F minus F, is ma. In this direction is balanced, so you have n minus mg equals 0. That defines your system. Now imagine you have a bit more complicated situation. So I put, this is the object, and then you have another object on top of it. So this is MA, B, and the force, for example, acts here. I just put it as an example. We could consider the whole system as your system, and therefore the environment act on this. So you have the MA plus MB times G. This is the gravitational force. You have a force reaction, normal reaction, N. You have the friction at the point of contact between the system and the surface. But what is important, the force between the two objects is internal force, so this won't affect the whole motion of the system. So if you write the equation of motion, this becomes similar to the previous case, and n minus na plus nb times g equals 0. Now this can be also considered, let's say, this object on top. Assume that is your system. So the analysis probably would become a bit different in that case. So this is A, this is B, and this is the object. Now I consider this as a system. You knew you have a force here. So the force then acting on this is a gravitational force. Then there's a force at the point of contact from the surface. This time the surface is the top surface of the A, which acts on the object, and we call it N A to B. Since B wants to move this direction, there would be a frictional force opposite to it, which is F A to B. Now F minus F A to B is MBA. This is the system, and NA to B minus MBG equals 0. This is the condition when you consider the top mass. Now imagine I move to the bottom MA, and I have MB and F. Now I consider A as our system. In this case, the forces acting on A from the environment, one of them is this pushing A in this direction, moving A in this direction. So this is B, this is A, it's pushing it. So therefore the friction acting as a force who moves A, not to stop A. And this is the friction B to A, I call it. But the force of friction at the contact between the bottom surface is F. This will want to stop it. Then you have MAG, you have MBG, you have also the normal force to the at the point of contact N, and this is the normal force from the top acting on B. So if you write the equations, FB to A minus A, F is MAA, and then you have N minus MA plus MB times G equals 0. In this case, this frictional force becomes a force that wants to move the object A. Now we can have also other systems with other conditions. I go further more. It can be, for example, inclined plane. Imagine, and you have the objects, let's say, sitting on top in this direction. This is B, this is A, and this angle is theta. And suppose I push A to this direction, pull it to this direction. In this case, if you consider the whole system as your object, then you have the mass of A and B, which is the mass of the system, divided by two components, one normal to the direction of motion and one parallel to the direction of motion. This one is always MA plus MB and G cosine theta. And I always, I don't go to details, I assume you know it, but it's just projection of the mass to these two directions. MA plus MB times G sine theta. So if this is the mass, and we know this angle is equal to this angle, therefore this is theta because the angle is perpendicular together, so this becomes the projection of the mass in A plus B times G on the normal direction to the equation of motion. This is also parallel. So if you have a frictional force and you assume this is the direction of motion, you can have also this direction of motion. If this is the direction of motion, then the friction is in this direction. If the opposite, then the friction is opposite. So F minus MA plus MB times G sine theta is equal to MA plus MB times A, and then N, I didn't draw N, minus MA plus MB times G cosine theta equal to 0. Here, this one I put N, F minus this. I have to have the frictional force.